Hey everyone, welcome to today's show. I've got Ronen here with Fluence, and we're going to talk about some different packaged decentralized wastewater and water plants. Thanks for having me on, or thanks for being on today.
Thank you for having me.
All right, so a lot of Colorado rural providers have existing lagoons, and they're having to update them and convert them and come in compliance with the new standards that are being pushed. How do you guys kind of handle and see some solutions to that problem?
Wonderful question. So we would tackle this in two ways. First of all, in Colorado, they're now imposing new total inorganic nitrogen requirements where you need to knock down the total nitrogen, I believe, to about 8 or 10 milligrams per liter. For that, we have our proprietary MABR technology. You can probably see it around the booth, which is basically a component that goes into the anoxic part of the biological reactor and basically enables you to simultaneously nitrify and denitrify in order to meet your TL limits. So we would, in those situations, we would implement the MABR element in order to hit those TIN levels, which is already permitted and been approved by the Colorado regulator.
What kind of limits do they get?
So we would actually target more stringently. We are specifically targeting the territories where TN levels are requirements are the lowest. So an example, in Maryland, they're required to meet ENR standards, enhanced nutrient removal standards, which leads you to knock down the total nitrogen to 3 milligrams per liter and your total phosphorus to 0.3 milligrams per liter.
Oh,
so these applications is where we shine because the alternatives are going to be much larger solutions in terms of retention time, which then translates to more expensive. The MABR allows us to get to the same limits, but with a much more compact solution or more intensive process. Okay, so we would definitely implement our proprietary MABR technology. But on top of that, many of those lagoons, they seem very large in size, but in reality, they don't treat that much flow on an average day, gallons per day flow. So let's say you have, 30,000 gallons per day. The way we view things is that we came up with our containerized solutions, okay, which we have our fundamental building block, which is a 40 by 8 foot shipping container. We manufacture these containers from scratch as water tanks, but we build them and certify them as marine shipping containers in order to reduce cost on anything that is associated with the logistics of moving it around, installing it, and so on. Now, the nice thing with that approach is that once you have our fundamental building block, which is 40 by 8, we can occupy it or the internals however we want, based on the application. So if the application already have a lagoon, we would prefer to utilize the lagoon instead of just demolish it, if it's possible, and then use the lagoon as our sludge holding tank, use the lagoon as our flow equalization tank, and then treat only what needs to be treated, like we're doing in Iowa, and now we're doing it in Missouri.
So that could be like if you needed 17,000 gallons influent EQ, you could utilize that and then build off of it.
Well, I'll tell you more. So, for example, in Iowa, we have a 30,000 gallons application. Okay, for a 30,000 gallon application, we have our Swiss Army knife building block, which is composed out of 2 MABR towers, and that's why I have my beautiful Lego demonstration. It was my dream to have old engineers in WEFTEC play Lego. We have our small fine bubble diffusion aeration compartment. It'll get followed by a circular clarifier. And then we will obviously control the whole thing in a cabinet, which will have on top of it tertiary filtration and chlorination or UV. This package can treat hydraulically up to 30,000 gallons per day. One of the challenges for the client in Iowa was that their lagoon did not discharge continuously through the year. They were allowed to discharge only during autumn and spring. The problem is that during those times, the lagoon at some point would be covered with algae, and they would get out of compliance with their BOD and TSS because the algae would die, and then would that increase your TSS or BOD trapping. So what they're doing with this, they took our Swiss Army knife and they start processing it. So they getting their nitrogen down. They don't have true total nitrogen limits, but the nitrogen is what enables the algae to grow. So the idea is to knock out the algae and that way prevent the algae from growing and then basically hitting their BOD and TSS limits. And that's why they have this little thing that is the side treatment to the lagoon and enable them to now safely discharge during their periods.
Neat. I got another question. What about kind of the operational efficiency of these units? Like an operator is used to just kind of showing up to a lagoon in these cases, and there's not really even maybe a control panel. Hardly. How is it navigating through one of these and maintaining the equipment?
So I appreciate the question. One of the nicest features about the MABR is that in America, I never lead with this because electricity is so cheap. But when it comes to Lagoon, it becomes relevant again. So not because we're saving a lot of energy. Of course, it goes a long way. But when you're dealing with, 30,000, a quarter of an MGD plant, you'll save energy, great. But at the end of the day, when you quantify it for how much you're saving a year, it's not going to be that great. But many of those lagoons are in such remote areas that supplying power there is going to be a challenge. If we can come up with a solution that consumes low energy, we can basically be able to utilize single-phase power in order to power the whole thing. Or our partner in Iowa is actually, the next step is to use solar panels in order to operate the whole thing, in order to demonstrate that.
I've seen that one before. Essentially, you can tie it with an energy grant.
Correct.
And kind of offset a lot of it.
That's right. So the MABR is a passive way to introduce oxygen into the wastewater, and that's why we're knocking down the energy associated with aeration by 90%. Which is your biggest energy consumer in the plant.
Yeah,
so right there, that's right. Right there, that's one good reason how to be able to enable these more intensive processes into area or locations where honestly there's no power. Now, obviously, we still need an operator. Obviously, this is a more high-end solution than a lagoon, so it does need somebody to visit it. But we require once or twice a week visit to the plant. The MABR component, honestly, does not have any element from an operation side. Even if you're the most enthusiastic operator on the planet, there's not much that you can really do. And I'm not going to take the time and take you through the MABR process, but I'm happy to do it at any given time. Basically, what this requires is a sludge judge for the clarifier. And I'm sure you're familiar with that. You go up, you dip a stick in the clarifier, see how tall the sludge got to, and then you decide if you're basically figuring out when you want to discharge. After you do that a couple of times, it all happens automatically. So one of the good things about technology today, as opposed to what Lagoons has happened, is that I can remote monitor and control and operate a system from my mobile phone nowadays.
Yeah.
It does not come instead of coming to the site because the regulator still requires monitoring and site visits. But honestly, everything can be done through their phone. And on top of it, as I mentioned, there is nothing new that we bring to the table. If you have a larger application and you want to use UF membranes as the solid liquid separation mechanism, like an MBR, obviously that's going to be more intensive. Fluence would able to offer that, but an MBR is an MBR.
Yeah.
Which is different than MABR. Completely different
things. Get that a lot.
Yes. So there's a lot of educational effort there.
Okay.
That one of the nice approaches about the containerized solution is that we don't mandate the client to get the whole solution. In other words, if the client already has a mean for flow equalization or sludge holding or liquid solid separation, we can basically just offer, here you go, is a standalone biological reactor. Here is a standalone containerized clarifier solution. Here is a standalone MBR container with the controls, with the UF membranes. Then you tie it into the existing infrastructure. Our approach is not to come in and completely replace the plants that they exist, because that's going to be very money extensive, and those rural communities don't have a lot of money.
No, they really.
So we're trying to help them exactly at what they need. So we would look at an application and see, what is your problem? Is it your liquid solid separation? Is it your biological reactor? Is it your equalization? What is it? And we will supply whatever is needed. And that approach allows us to do it in a very cost-efficient way.
That's a great point. So essentially what you're saying is, you can come in and just add a step you could add a step, change a step, or kind of combine two kind of in your solution.
I hope I won't get sued by another company, but I call ourselves the IKEA of package plants.
IKEA.
Okay, it is as simple to install. During the pandemic, when we shipped those, our engineers or technicians were not allowed to travel. So that means we sold systems, we shipped them, and we needed to remotely explain to the local GCs how to install these and how to commission them. And we did it in a few days. It's as simple as an IKEA instruction manual that you get. It's pretty much that, because once everything is pre-designed, pre-engineered, and factory tested, you came to the site, the amount of labor on site is minimal. It's about connecting a couple of pipes, and that's it. And so I think that goes a long way, especially in America where labor is so expensive.
So expensive. Awesome. Thank you very much for taking the time to chat with me today.
I appreciate it. Thank you.
That was great.